Hello, my dear students of 6th semester Electrical as well as Electronics and Telecommunication Engineering Department. Today I am here with you, Lalit Kumar P. Bhaiya, Associate Professor, Electronics and Telecommunication Engineering Department, Bharati College of Engineering and Technology, Durg. Dear friends, today we will go through the very basic fundamentals of the digital signal processing in terms of discrete time signals and systems. Let us go and see what are the basic things. Here we will learn today discrete time signals and system as an introductory part. The taxonomy of the signal. Signal, a function that conveys information. Here you can see in time domain, continuous and discrete time systems are there, where amplitude may be also continuous and discrete. Time is continuous, amplitude is continuous, called as the analog signal. Time is continuous and amplitude is discrete, called as a continuous time signal. The discrete time continuous signals and discrete time discrete signals, that is discrete time and discrete amplitude, called as a discrete digital signal. What is digital signal? Digital signal is the discrete time and discrete amplitude signals. These are the digital signals. Then signal processing system, we will apply the signal and we will get the output here. To facilitate the extraction of desired information, we will apply the signal to the signal processing system. We will get the output as shown in this figure. Facilitate the extraction of desired information, like filters. We will use the different parameters for estimation. Here you can see continuous time signal is applied to the analog system. We will get the continuous time signal. And the discrete time signal we will apply to the discrete time system. We will get the discrete time signal. And the digital signal is applied to the digital system. We will get the digital signal. This is the basic differences: continuous time signal, discrete time signal, and digital signal. An important class of system is plays an important role in case of the digital signals and system, called as a linear shift invariant system or linear time invariant system. It is also called as LTI systems. In particularly, we will discuss linear shift invariant discrete time system, that is LTI DTS, discrete time system, and we will go through the separate videos on the LTI system also. Let us go the brief and basics of the sequences. Discrete time sequences represented by x of n. This is called as representation of discrete time sequences. Concerned with processing signals that we are represented by sequences. You can see here this x is represented by x of n, where n is greater than minus infinity and less than infinite. And this sequence is shown in this graph. You can see here this is x of n, which is less than minus infinity and greater than minus infinity and less than infinity. This type of representation is there for the discrete time system. Here the most important sequence used in DSP is the unit sample sequence, or it is also called as impulse function, that is del of n. del of n is equal to 1 for n is equal to 0, and del of n is equal to 0 when n is not equal to 0. This is the graph of the impulse function, that is unit sample sequence. Only at this n is equal to 0 it is 1, otherwise everywhere it is 0. Practically this signal is not possible, but the train of impulses can be obtained. Here you will get the train of impulses, and we can use the particular weightage on the particular n of the signal. Unit sample sequence, sometimes we call it as a del of n, or it is impulse function, a discrete time impulse, or an impulse simply, that we have already seen. Then unit step sequence, that is represented by u of n. So u of n is equal to 1 when n is greater than or equal to 0, and it is 0 when n is less than 0. This is the u of n, and this is the sequence shown here as a u of n, that is unit step sequence. It is looking like a step like this, so therefore it is called as a unit step signal. Here all the values are 1, and here all the values are 0. So for n is equal to 0 and greater than 0, the function has a value amplitude 1 here. So this is unit step sequence. Then, in fact, this del of n, that is unit impulse function, is equal to u of n minus u of n minus 1. This is the relation between impulse and this step sequence. This is the impulse sequence, and this is the step sequence, and this is the step sequence delayed by 1 samples. So del of n is equal to u of n minus u of n minus 1. You can verify this sequence by putting different values of n from 0 onwards, and you can see this del of n is nothing but this one, u of n minus u of n minus 1. You will get only one sequence at n is equal to 0. So this is the important sequences. Then real exponential sequence is given by x of n is equal to a to the power n, and this sequence can be drawn here. This is a to the power n sequence, x of n. This is called as a real exponential sequence. So real exponential sequence can be shown like this. And then sinusoidal sequence. As usual in our time domain, we can represent this sinusoidal sequence continuously like this. Here in discrete time, these times are discrete. This is n is equal to 0, this is n is equal to 1, n is equal to 2, n is equal to 3, n is equal to 4, 5. Similarly, n is equal to minus 1, minus 2, minus 3, minus 4, minus 5, and this is discrete time sinusoidal sequence. This is represented by x of n is equal to a cos n omega 0 plus phi, where a is the amplitude, n is the discrete time, omega 0 is the frequency, and phi is the phase angle. This phase angle phi can be represented with this sinusoidal signal. Then complex exponential sequence. Complex exponential sequence is given by x of n is equal to e to the power sigma plus j omega naught n. Or if you extract this real part, if you don't write this real part, you can write e to the power j omega naught n is a complex exponential sequence. So this complex exponential sequence plays an important role in digital signal processing. And this signal may be, you can see here, structure of this signal may be like this. If you see this signal, you will get this exponential like this, and this is exponential. This is again, it is exponential signal you will find here. Then a sequence x of n is defined to be periodic with a period of n if x of n is equal to x of n plus n for r values of n. This capital N is called as a period. It is a number of samples. Let us say if we have capital N is equal to 10, then it is a period of 10. If you consider capital N is equal to 8, it is a period of 8. After every 8 sample, the same signal you will obtain here. X of n is equal to x of n plus n. That means after, if I consider capital N is equal to 8, after every 8 samples, you will get this original signal. So this is called as the periodicity. In terms of time domain, you can write x of t is equal to x of t plus capital T, where capital T is the period of, in case of the time domain. In time domain, you can write x of t plus t. So this type of signal can be periodic signal. Here, consider this x of n is equal to e to the power j omega naught n. Omega naught is the frequency. Then x of n is equal to e to the power j omega naught n. It can be written as e to the power j omega naught n plus n, where this capital N is the period. It can be written as e to the power j omega naught n into e to the power j omega. You can separate this. This is nothing but x of n plus n. So this is called as the property of the periodicity. So using property of this periodicity, you can get the signals like this. And here you can have omega 0 n is equal to 2 pi k period, and this capital N is equal to, you can write 2 pi k by omega naught, and this can be written as 2 pi by omega naught. Must be a rational number. So this is a property of periodicity. Similarly, energy of a sequence is defined by this formula. Energy E is equal to summation n is equal to minus infinity to infinity magnitude of x of n whole square. This is comes from the Parseval's theorem, and hence this energy of sequence is given by this formula. N is equal to minus infinity to n is equal to infinity magnitude of x of n whole square. This is called as energy of a particular sequence. So dear friends, today we will stop here. Next time we will continue. We will go through the operations of the sequence. Thank you very much. If you have any doubts, you can ask me at any time on any platform, either on email or on WhatsApp or on phone call, or when college starts, in college also. So you can ask any doubts at any time. I will be always with you. And do study properly. You are at home now. Please try to do better and better. Thank you very much.